Good morning, everybody. Welcome to today's lesson. Today is 3/23/2020. Let's learn together. Now, we're going to move on to our third grade skill, which our third grade skill is going to be going back to what we learned before we went on a break. Now, what we learned before we went on a break, we were talking about equivalent fractions as well as comparing fractions. So, today's learning intention for today's assignment is I am learning how to represent equivalent fractions with denominators of 2, 3, 4, 6, and 8 using a variety of objects and pictorial models including number lines. See, we're just going back to what we've learned before we went on the break. Now, the first thing I want to do is go over equivalent fractions. Equivalent fractions are equal or the same to each other. They must be the same size and same shape to be equivalent. Now, equivalent fractions can also be defined as fractions with different numerators and denominators that represent the value or proportion of the whole. So, as long as they are the same size and the same shape, they are equivalent, right? It tells you right here, equivalent fractions. 1/2 equals 2/4 equals 4/8. You see how the numerators and the denominators are all different, but they're all proportionate to each other. They're all the same size. That's what makes them equivalent. I also put examples of not equivalent fractions. Not equivalent fractions look just like this. 1/2 is bigger than 2/6, so they're not equivalent. They're not equal. They're different sizes. Same thing with 3/8 and 1/2. You see how 1/2 is still bigger? So that's just a refresher on equivalent fractions. They must be equal or the same to each other. Now, let's take a look at this question that we went over before we went on the break. So Mr. Guerra and his wife went out for pizza. Mr. Guerra and his wife ate equal amount of pizza. Which model represents the amount of pizza that Mr. Guerra and his wife ate? Well, I'm going to underline the question too because I need to know what the question is asking me. In this case, it's asking which model could represent the amount of pizza that Mr. Guerra and his wife ate. You know, and we know that they ate equal amount of pizza. Okay? So equal means the same, right? So here are the models. There's the first one, there's the second one, third, and fourth. Well, by looking at these models, I can already eliminate 2 of these right off the bat. Because when I look at this number line, I look at those numbers right there, right? Even though the points are directly halfway in between both those numbers, they equal something different. This is just to 1 and this one's to 2. So no, they are not the same. That one gets eliminated. Now, this one, yes, they both do have 8 equal amounts. However, this box is telling me 2 and this box is telling me 4. So is that the same? No, it's not. They're not equal. So those 2 get eliminated. Well, here's where it gets a little bit tricky because right here I have 8 equal slices and I have 4 slices that are shaded. Here I have 6 equal slices and I have 3 slices that are shaded. All of these right here equal 1/2. So should that be equivalent? Well, maybe because they're all 1/2, right? So now I'm going to go to my last model, showing me the representation of one whole. They're all the same size. This one's telling me it's 4/8, 4 shaded parts, 8 equal parts. Here's 2 equal parts with 1 shaded part. So that's equivalent also, because 4 is half of 8 and 1 is half of 2, right? So, but this one's also telling me that 4 is half of 8, 3 is half of 6. So that's 1/2 as well. But here's where it gets a little bit tricky. Remember I told you equivalent means the same size and same shape? Well, those are the same size, those are the shapes, same shape. But these are the same shape. But guess what? They're not the same size. This one is bigger than this one. So that would be your answer for finding an equivalent fraction that way. So let's move on. Another thing we went over before we went on the break is comparing fractions. Now, when you compare fractions, you need to use the symbols greater than, less than, or equal to. Well, examples to use the symbols greater than, less than, or equal to compare the fractions given. Well, remember I told you before the break that whenever we're comparing fractions and we see that the numerators are the same, which is the top number, we compare the denominators, which is the bottom number. Well, when you're looking at the denominators, the smaller the fraction, the bigger the number. Remember? The smaller the fraction, the bigger the number. So whenever we're comparing this first set of fractions, is I see that the numerators are the same. Now I'm going to compare the denominators. Well, automatically I see that 4 is a smaller number, so it's going to be greater than 3/8. Okay? Remember, when the numerators are the same, compare the denominators. The smaller the number, the bigger the fraction. Okay? Now, let's move on to whenever the denominators are the same. Denominators are the bottom numbers again. Whenever the denominators are the same, you compare the numerators, the top numbers. Now, this one's different because with the numerator, when the numerator is bigger, the fraction is bigger. So, when the denominators are the same, compare the numerators. The bigger the numerator, the bigger the fraction. So right here, 2 is bigger than 1. So 2/4 is greater than 1/4. Now, let's take a look at 1/3 and 2/6. Well, whenever we're comparing fractions that have a different numerator and a different denominator, we need to find a relationship between both of those. Okay? I know a lot of y'all automatically gonna think that 1/3 is greater than 2/6 because the denominator is bigger than 6, right? Well, that's not the answer. Okay? So whenever you have a numerator and denominator that are different, you need to draw a model. Okay? You must draw a model to figure it out. In this case, I'm going to use circles. There's one circle. There's two circles. I'm going to draw that one a little bit better. There's two circles. Now, the first one, I'm going to separate it into 1/3. Okay? So, 3 equal parts. Second one, I'm going to separate into 2/6, which is 6 equal parts, right? 6 equal parts. So now I'm going to finish the fraction. I have one shaded part, so I'm going to go ahead and shade one part of this. Okay? Now I need to shade 2 parts of this one. So I'm shading 2 parts. Okay, after I get that done, I automatically look at this picture and say, these look exactly the same, right? They look exactly the same. So I'm going to say that for right now, these are equal to each other. Then I'm going to find a relationship. What could be my relationship between these two fractions? Well, 1 times 2 equals 2. 3 times 2 equals 6. So, yes, these are equivalent. These are equal to each other. See how we compare fractions? Very easy, right? So, again, when you're comparing the fractions and the numerators are the same, look at the denominators. The smaller the denominator, the bigger the fraction, okay? When your denominators are the same, look at the numerators, okay? The bigger the numerator, the bigger the fraction. And whenever your numerator and your denominators are different, draw a model, okay? Draw a model. That's going to tell you which one is bigger, which one is smaller, or if they're equal to each other, okay? So, equivalent fractions. Equivalent fractions must be equal, the same size, same shape. Comparing fractions. Find the bigger number, find the smaller number, or if they're equal, okay? I can't stress this to y'all enough. Whenever you're comparing fractions and your numerators are the same, compare the denominators. The smaller the denominator, the bigger the fraction, okay? Now, your numerators are the same, or when your denominators are the same, compare your numerators. The bigger the numerator, the bigger the fraction, okay? And if both your numerators and your denominators are different, draw a model. Draw it out. I guarantee you it's going to tell you which one is bigger, which one's smaller, or if they are the same size. So that's your lesson for today, Mustangs, and I'm going to be posting a lesson on Google Classroom. Thank you for all your hard work and continue doing what you're doing. See you again tomorrow. Bye-bye.